All right, let's talk about a really cool evolution in AI called GraphRAG. You know those times when a simple search just isn't enough? When the answer you need isn't just sitting in one document, but it's hidden in the connections between a bunch of them. Well, that's exactly what this is for.
So let's just jump right in with a challenge. Imagine you've got this massive knowledge base at your company. How in the world do you answer a question like this? A normal search, it's going to find a document about the CTO, sure, and it'll find another one about authentication. But connecting the two, that's where things usually fall apart.
You see, the standard way we do this now is with something called Retrieval Augmented Generation, or RAG. And look, it's a fantastic technique for what it does. It's really good at finding chunks of text that are thematically similar. You know, stuff that just kind of sounds like what you're asking for. But it has one big blind spot.
And here it is. Standard RAG is pretty much blind to the explicit, hard-coded relationships between things. It doesn't really understand what reports to or depends on or evolved from actually means. It just sees a bunch of words that seem related.
And that is precisely where GraphRAG comes into the picture. It's this brilliant hybrid approach that combines the fuzzy, semantic searching power of vectors with the rock-solid structure of a knowledge graph. Just think of a knowledge graph as a map of your information, showing not just the places, the entities, but the roads that connect them all.
Now, what's really interesting about this slide is how it breaks down the two superpowers at play here. Vectors, on the left, they're like your bloodhounds, sniffing out concepts that are semantically similar across a vast landscape of text. But the graph, on the right, that's your detective, carefully tracing the explicit connections, allowing for what we call multi-hop reasoning. GraphRAG gives you both the bloodhound and the detective.
Okay, so this all sounds great in theory, but how do we actually create this knowledge web? How do you go from just a pile of documents to this intelligent, interconnected map? Well, it's actually a pretty elegant two-step process that uses an LLM to do the heavy lifting.
So first, you pretty much unleash a large language model on all your text. Its job is to read through everything and act like a super smart librarian, identifying the key people, places, and things, the entities, and, most importantly, how they all relate to each other. Then you just take all that structured gold and load it into a graph database, which actually builds out that web of knowledge for you.
And this is a perfect little snapshot of what that LLM is looking for. It's not just finding a thing like API v2. It's finding that critical piece of context, the relationship, the fact that API version 1 evolves to version 2. That single link tells a story that would be completely lost in a normal text search.
So, our knowledge web is built. Now for the fun part. Let's see this thing in action. How does the system actually use the graph when you ask it a question? It's not a simple one-and-done lookup, it's this really clever hybrid flow.
Okay, so here's how it works. Step 1, a normal vector search kicks things off to get us into the right neighborhood. Then, from those first results, we pull out the key entities. And now, here's the magic. We use those entities as starting points to literally walk around our knowledge graph, hopping across connections to find related ideas we might have missed. Then we go grab the documents related to those new finds, bundle all of this amazing context together, and hand it to the LLM to write a beautiful final answer. So let's go all the way back to our original head-scratcher. With this hybrid approach, a question that was basically impossible before is now totally solvable. Let's trace the path it would take. And this brilliantly illustrates what we mean by multi-hop reasoning. The system starts at the CTO entity. Hop 1, it follows the manager's relationship to find the engineering leads. Hop 2, it follows the next manager's link from the leads to their engineers. And the final hop, it follows the works underscore relationship to see which of those engineers are connected to the authentication project. Boom! The path is clear, the answer is found.
Here is another absolute classic problem, especially if you deal with any kind of complex software. You might have two services that never mention each other in a single document, but you know they're connected somehow.
This is where GraphRAG is just amazing. It can uncover these hidden dependencies. It might see that service A makes a call to an API gateway, and then discover that the gateway has a rule that routes traffic over to service B. It's a connection that's totally invisible to a text search, but plain as day on the graph.
How about this one? Understanding how things change over time. This is another area where just looking at individual documents is a nightmare. You really need to see the sequence of events.
The graph can model this perfectly. The evolved _2 relationship acts as a bridge connecting the two versions. Then you have these other relationships branching off of API v2, telling you exactly what was added, like OAuth support, and what was taken away. You get a perfect, crystal clear summary of the changes. So this all sounds incredibly powerful, right? But does that mean it's the right tool for every single job? Not at all. And that brings us to our final and maybe most important section. A simple framework to help you decide when you should and maybe when you shouldn't use GraphRAG.
The bottom line is pretty simple. You want to reach for GraphRAG when your questions are all about tracing connections. Think org charts, system dependencies, supply chains, and when those relationships are the whole key to the answer. But if all you need is a simple fact lookup, what is X, then the extra complexity probably isn't worth it. Standard RAG is your friend there. And really, it all comes down to this one idea. If you're just dealing with a collection of disconnected facts, you might not need this. But if the real insight, the real story is told by the relationships between those facts, then GraphRAG is an absolute game changer.
And remember, the real power here comes from that beautiful fusion of two different but totally complementary technologies. You've got the semantic intuition of vectors working hand in hand with the logical reasoning of graphs. It's a combination that gives you insights neither one could ever achieve on its own. And that leaves us with one final big question to think about. We're moving past just retrieving information. We're teaching AI to understand systems, to see context, to grasp dependencies. So what happens when our AI doesn't just know a list of facts, but it truly understands the intricate web of how everything is connected? That's a pretty exciting future.